Every single time you send an email, stream a show, or just browse a website, you're interacting with this hidden, totally invisible layer of the internet. It's the part that makes everything you do online actually possible, yet most of us never even think about it. Well, today, we're going to pull back that curtain.
So, here's the plan for this explainer. First, we'll connect this whole idea to the apps you use every day. Then, we'll get into what the application layer actually is, and the languages it speaks. After that, we'll check out the two main ways networks are built, and we'll wrap it all up with why this layer is really the foundation of our entire digital world.
All right, let's kick things off with something we all know, our favorite apps, and see how this invisible layer is working behind the scenes literally every single day.
So, seriously, have you ever stopped to wonder? You tap an icon, you type in a web address, and bam, like magic, a whole world of information just appears. But what is really going on there? What's the secret sauce that connects your simple click to the massive, complex beast that is the internet?
Well, it's not actually magic, though it sure feels like it. The answer is an invisible bridge. It's a layer of technology built for one specific purpose: to connect the apps we understand with the super technical, complicated network that we don't. And this bridge, it has a name.
And that bridge is the application layer. So let's really define what this thing is and see how it works as our personal gateway to the entire network. Okay, to really get where this layer fits into the big picture, you can look at this thing called the OSI model. Think of it like a map for how networks talk. It breaks everything down into 7 layers, and our application layer, layer 7, is sitting right there at the very top. It's the highest level, the one that's closest to us, the users.
So, what's the official definition? Well, the application layer is the part of the network that creates a direct link, an interface, between the apps you use, like your browser or your email, and all the network services running in the background. It's what lets your software actually talk to the network. So what does this layer actually do? What's on its to-do list? Well, basically all the things we take for granted. It provides the network services we need, like, browsing the web or downloading a file. And this is huge. It lets totally different software programs talk to each other. Think about it. Your Gmail app on an Android phone can perfectly send a message to someone's Outlook on a Windows computer. That's the application layer making it happen. When you share a Google Doc, it's handling that collaboration. And it even helps your app show you network information in a way a human can understand. It turns all that raw data into the web page or email you actually see. It just makes everything easy.
Now, for the application layer to do all this incredible work, it can't just be sending random signals back and forth. It needs to speak specific languages. And in the network world, these languages are called protocols. They're basically the rules of the conversation. Now, there are a ton of these protocols, but let's just focus on 3 of the absolute biggest ones you use every day. You've got HTTP, which is the language for web browsing. Then there's DNS, which is kind of like the internet's giant address book. And SMTP, which is basically the postman for all your email. All right, first up, HTTP, the Hypertext Transfer Protocol. This is the bedrock of the World Wide Web. Every single time your browser loads a web page, it's sending a little HTTP request to a server, and the server sends back all the page's data using that same language. It's the standard that makes the web, well, the web. Next, we have DNS, the Domain Name System, and this one is an absolute lifesaver. See, we humans are good with names, like example.com. But computers, they need numbers, these long IP addresses, to find anything. DNS is the incredible global system that does that translation for us, from name to number in a split second. Without it, browsing the web would mean memorizing strings of digits. No thank you. And finally, SMTP, or Simple Mail Transfer Protocol. This one's easy. Every time you hit send on an email, SMTP is the protocol that grabs your message, pushes it from your app to your mail server, and then makes sure it gets passed from server to server across the internet until it lands safely in the right inbox.
Okay, so we've got the layer, and we've got its languages. But how are the networks themselves actually structured? This brings us to network architectures, where we can explore the different blueprints that our digital world is built on.
So at a really high level, there are 2 main ways to build a network. On the left here, you can see the client-server model. See how everything connects back to that one central server? Now look to the right. That's a peer-to-peer network. All the devices, or peers, are just connected directly to each other. There's no central boss. Let's try an analogy to make this clearer. The client-server model is like a big public library. You have one central building that holds all the books, and tons of people, the readers, come to it to get what they need. The peer-to-peer model, on the other hand, is more like a book club. Everybody brings their own books, and they just share them directly with each other. No central librarian required.
So let's break down the pros and cons. The client-server model is centralized. That makes it really easy to manage and scale up. But, and it's a big but, it has a single point of failure. If that server goes down, everything goes down. The peer-to-peer model is decentralized, which makes it super resilient and cheap to run. The downside? That lack of central control can lead to security issues. Your everyday websites and email use the client-server model, while P2P powers things like BitTorrent and blockchain technologies.
Okay, let's wrap this all up. Let's get to the real heart of why this invisible layer matters so much, and why it's truly the foundation of our digital world.
So here we are, back at that full model. Just look at all the complexity going on underneath the application layer, all the physical wires, data packets, and network routing. The application layer just sits right on top of all of that, basically shielding us from it all, and translating the network's raw power into actions we can actually perform.
So, when you boil it all down, the application layer is the great translator. It's the human-friendly face on an unbelievably complex machine. It takes the powerful, messy, abstract world of network communication and makes it simple, understandable, and, most importantly, useful for every single one of us.
And that kind of leaves us with a final thought, right? The most complex systems we ever build so often end up having the simplest interfaces. So what does this invisible architecture, this layer that's totally focused on the user, really reveal about the technology we choose to build and what we value most in our digital lives?